PROG7312 POE video demonstration of why we use File Service app. First, we'll do the code explanation. For part 1, we had to initiate the report issues function. The data structure we used in this part was a list, which is a built-in list. There is two lists we used, an internal and an external list. The internal list can be found in the report issues.cs programming file. The internal list is the same as the class as the report issues, as this is just for internal storage to make sure the issues are being stored one after the other with a unique ID. The externals list is stored in the shared data modules.cs file. We have the external list so that the other class can access it and add it to the information or data structures. We have a progression bar, which you'll see in the actual application part of it later on, which shows the user that there are still things to be done before submitting an issue, and a feedback label under the progression bar to tell them what each section is for. It is used as user feedback and motivation. For part 2, we have to initiate the local events part. In the local events.cs part, all the data structures we used are stored here. The local events is just a screen where we basically view upcoming events and not add events. The data structures we used is a dictionary, a sorted dictionary, a hash set, queue, stack, and a priority queue. The dictionary allows us to store all events individually and uniquely to search easily. The sorted dictionary stores the events according to date to search easily. The hash set stores all the categories and we can check all the events in that category. The stack is used to keep track of recently viewed events that a person searches from bottom to top. The queue is to put them in order from upcoming events from top to bottom. Part 3, view request. We used 4 data structures: a dictionary, a binary search tree, AVL tree, and graph. What did we use them for? The dictionary, which can be found in the check status CS file and the shared data module.cs file. The dictionary stores all requests from report issues to view requests. The graph shows dependencies between the requests. The dependencies, for example, I cannot look at request 2 until request 1 is complete or fixed. So the graph shows these dependencies. The binary search tree and the AVL tree both store the same thing. It's used as comparison and quick searching. All of them store the requests according to their ID. The reason for using the AVL tree and binary search tree is because they're easy and quick to use, insert and search. In the video demonstration, we can now go into the app. We're going to report issues. We will report an issue, ward 30. And as you can see, you can change the different screen sizes. We'll use our custom feature where you can put your own label. We'll just call this one emergency alert. We'll say hailstone warning, and we can add our attachment. And also the buttons are cut in half due to the fact that my laptop screen is small, so please do forgive me for that. Then in the local events, and also just a heads up, we do have preloaded data on here for video demonstrations, which you can see here in the local events and in the view request status part, which you will see. So here you can search via category, you can search sanitation, search, you can see it there. You can also clear the filter, search via the keyword, search, and it will come up. Then you can search via the dates as well. Search, and then you can see what comes up in the upcoming events. Then go back to menu, go to view request. As you can see, the preloaded data is the first 3, and then I've added 15. You can view their statuses, you can search via the ID, which is what is needed. Press search, Then you can see what issue was reported with the ID, clear the filter, and then search via one of the new ones we added, which is ID1, and then search, and it'll pick up the issue that was reported. Thank you for watching my PROG 7112 POE video demonstration.